All right, guys, here we go. 9.3 lecture notes. So get your notes out in front of you. I know that there's 4 pages, just like there was for 9.2, but make sure you get that out. Let's roll with this. So description, what we're doing today and our objective. So describe how food production contributes to environmental issues, as well as understand how those environmental issues impact not only food production, but also food security. Okay, food security and insecurity, that was 9.1. That's a very, very big thing on this unit. Basically making sure people are able to get food and consistently able to get food. All right, here's their key terms. So make sure to flip back to your vocab, write these down. As we're going through the 9.3, I will pause and say, hey, remember, topsoil is one of them. So go back. But during this lecture, I'm not going to pause for 20 seconds for you to do that. All right, I'm expecting you guys to do the pause and read and take notes and this, that, and the other. All right, here we go. So how are environmental issues and food production connected? So food production can cause soil erosion. It can cause desertification. It can cause irrigation, water storages, air and water pollution, climate change, loss of biodiversity, whole bunch of different things. All of those can limit the potential of future food production. All right. So large inputs of energy are needed to grow, store, process, package, transport, refrigerate, and cook plants and animals. There's a ton of energy going into it. We're talking about industrial agriculture the other day. We were talking about how big those John Deere tractors were and all the fossil fuels that they use. There's a lot of high input into food production. And then once it gets to the grocery store, a lot of input to keep the stuff cold. Okay, and then once we get home, then we got to drive to the store, drive back. Once we get home, energy in the refrigerator, energy in the stove, energy in the oven, and so on and so on. There's a lot of energy going on. All right, in the United States, 10 units of fossil fuel energy are needed to produce 1 unit of food energy. All right, that's a lot. So basically, we're losing a lot of fossil fuels simply to food or simply to feed people. All right, fishing fleets, they're using 12.5 units. So this is, again, kind of like we're talking the other day about how aquaculture is becoming really, really, really popular. This is one of the reasons why. Industrialized food production is dependent on fossil fuel, resulting in obviously a net energy loss of this whole thing. All right, while industrial agriculture has allowed farmers to use less land to produce more food, remember that's green revolution, same 10,000 acres, and now you're making 200,000 pounds of food rather than 100,000 pounds of food. That's green revolution. It's environmentally and economically unsustainable, though. All right, industrialized agriculture removes 70% of fresh water from surface sources and aquifers. 70%. So that leaves only 30% for commercial use or residential drinking water, as well as residential irrigation of their plants and their landscaping, which, side note, is a lot of water we use that way. Okay, uses 38% of the world's ice-free land, emits 25% of all greenhouse gas emissions, and produces 60% of all water pollution. Again, from an environmental standpoint, industrialized agriculture is terrible. But remember, environmental science, we got to take into account both the societal impacts and the environmental science, or the environment and the societal impacts. And this is allowing us to feed 8 billion people. So it's kind of a hard solution for this whole stuff. All right, topsoil. Okay, this is one of your vocab words. So topsoil is the fertile layer of many soils, the fertile top layer of many soils. It is a significant natural capital component because it stores water and nutrients needed by the plants. So if you went into your backyard and you started digging into your yard, you will find that there's a layer, depending on where you are, anywhere from like 1 inch to 5 inches thick, that's really kind of like a brown, real earthy, healthy looking color. Then underneath that, it typically becomes like a more light brown, a little bit more like dead looking, which is a weird way to say it, but like it's drier. It doesn't have as much like kind of texture to it. It's real, like if you pick it up in your hand, it just flows out like sand. So basically there's the topsoil, that's all the nutrients, real close to the surface. And then there becomes more like the bedrock and foundation underneath it. All right, topsoil, that's how you grow your stuff. If you go to the Home Depot and you're buying soil, you're buying topsoil, basically. All right, topsoil renewal is one of Earth's most important ecosystem services. That's one of the reasons I do composting. Compost creates new topsoil for me. All right, topsoil nutrients recycle endlessly as long as they are not removed faster than natural processes replace them. One of the big ways they get removed is soil erosion. So like you guys know what tilling is, kind of like tilling the earth, kind of churning it up. If you till up the soil like that, and then there's big storm or big wind, it's literally going to blow that topsoil away. If you guys remember from history class, the Dust Bowl is when the topsoil literally just got blown away. All right. So you can see on the left-hand side here, this is basically immature soil. Then you have young soil, and you have mature soil. So you can see basically it's going from basically bedrock to a little bit of dirt, and then you can see how it's becoming darker, like I was saying on the top. That's the really quality topsoil there on the top. All right, soil erosion. Okay, movement of soil from one place to another by nature or by human activity. All right, like we've talked about, remember, like clear cutting, if you take all the trees out, soil erosion is going to happen. Water just takes it all away. Okay, that would be happening by nature. Human activity, that's when, like, you get a big backhoe in there, you need to take all the soil because you're going to sell it somewhere else or something like that. All right, flowing water, that's the largest cause. We've talked about that before. Wind loosens and blows it away, just like in the Dust Bowl. Okay, farming and deforestation and overgrazing exposes the land and hastens soil erosion. That overgrazing, remember I was talking about that. Like the cattle will eat and eat and eat the grass, and eventually to the point where they're taking a little bit of grass, and they're taking a little bit of grass, but then they're also pulling up some roots. That will cause soil erosion because then basically there's nothing to hold on to the soil. The soil just goes away. All right. Harmful effects of soil erosion: loss of soil fertility. Basically, you can plant stuff all day long, but it's just not going to grow. That's the problem. All right, sediment pollution of surface waters can kill fish and clog reservoirs and lakes. Think of the Mississippi River and think of the Gulf of Mexico dead zone. This is one of the reasons. Okay, increased if it contains pesticide residues. This is the non-point source pollution. All those farms draining into the Mississippi River, all of that stuff gets kind of compounded there. The erosion releases the soil's carbon content as well, which alters the carbon cycle, adding atmospheric levels of CO2. CO2 is a greenhouse gas. Now our planet's getting warmer. All right. Now there's soil pollution as well. So some chemicals emitted into the atmosphere can pollute the soil or the irrigation water. So we'll go back to real quick. So we're talking about here the sediment pollution of surface waters. That right there, that's what I'm talking about for this irrigation water. If you get a whole bunch of crap into the water, you don't want to use that water to water your crops, or else you're just putting bad water on your crops, going to kill your crops. All right, sources: industrial plants, power plants, motor vehicles do this stuff as well. 19% of China's farmable land is now contaminated because they have really bad air quality, which gets into the water, and so you can't really water the crops with that stuff. All right, now careless application of pesticides. We talked about this. This is DDT. You just kind of spray it everywhere. It's going to contaminate the water supply. Fertilizers for agriculture can also pollute the soil, and pollution can spread to nearby organic farms. So if you're right next to, like, let's say you have 1,000 acres and you're right next to 10,000 acres of industrialized agriculture, that fertilizer and that crap can get onto your farm, and you can no longer be considered an organic farm anymore. All right, desertification. This is also one of your vocab words. Soil desertification. Process by which productive potential of topsoil falls by 10% or more due to human activities. Okay, so human activity could be something like tilling the soil. Okay, then the storm comes through, wipes it all away, or the wind comes through, does the Dust Bowl again. Desertification, basically you're making what was fertile land and you're messing with it so much that it can no longer basically be fertile land. Okay, this is overgrazing, this is deforestation, excessive plowing, can cause desertification. Extreme cases lead to desert-like conditions. This right there, that's the Dust Bowl. Okay, all the topsoil went away, leaving just bare soil that's really crappy on the bottom. That's basically a desert-like condition at that point. All right, agriculture activities have serious environmental consequences. So the irrigation boosts and lowers farm productivity. All right, so it boosts it in the short term because irrigation, remember, is just simply watering things. So by watering your crops, that's great. That's going to boost productivity right now. But if you do it too much, the soil becomes not as good. So in the long term, the productivity is going to go down. 70% of human water humanity uses goes to irrigation. All right, and then irrigation water has a variety of salts, which leads to soil salinization. Okay, having a variety of salts, not a bad thing. It's still considered fresh water. So like the water you get from the tap has salt in it, like your body needs the salt. All right, but if you do too much of it, that's where it leads to kind of in the long term, it's not going to be very good. It's going to stunt crop growth and lower yields, and eventually kills all the plants, and all the land is done for. At least 10% of the world's irrigated cropland suffers now from soil salinization or salinization. Side note: this is one of our where's soil salinization? Waterlogging from, I have it written there. Okay, so this right here, I'll put that up. Waterlogging from irrigation, raises water table, and so on. So soil salinization, your word there is basically, since you are irrigating your crops or you're watering your crops with water that has salt in it, if you do that too much, all that salt that you're putting on your crops, that salt stays there, but the water either A, gets absorbed by the plants, or B, evaporates. So the water leaves, but the salt stays. If you do that process enough times, now that soil has way too much salt. That's soil salinization. All right, so in your definition for your words, write something to the effect of too much watering leaves all the salt behind, making the soil too salty, or some sort of that version. All right. Now, agriculture contributes to air pollution and climate change. So the impacts of the growing crops and raising livestock, So clearing and burning of forests to raise crops and livestock to add dust and smoke to the air. So think about like if cattle are all walking around, they can see kind of like the dust trail behind them. Using pesticides and fertilizers adds chemicals to the air because you're spraying pesticides. 100% of it doesn't get on the plant. Some of it just goes into the air. The wind takes some of it away. Okay, the ammonia from livestock, their pee, by the way, can lead to acid rain, alter chemistry of terrestrial and aquatic ecosystems. Remember I was talking about that CAFO, the concentrated animal feedlot operations, all their pee and poop, they just put in a big gigantic lake. That right there is what we're talking about. Okay, that water starts to get evaporated or that water starts to flush out. All that acid goes up, creates acid rain. Okay, agriculture accounts for more than 25% of human-released CO2 emissions and the release of CH4, which is methane, and N2O, which is nitrous oxide. Okay, that's manure and synthetic organic fertilizers. All of those are very bad for the air quality. All right, biodiversity loss during food production. So clearing and burning forests leads to loss of natural biodiversity. Straightforward. There's a forest, you chop it down, the things that were living there obviously aren't living there anymore. Diversity drops. All right. Deforestation in the Amazon basin and for clearing for grasslands for cattle ranching and plantation farming, that's decreasing biodiversity. Everybody knows about that slash and burn agriculture that they've been doing. So there's fewer varieties of animal plant species now used in farming. So there's less agrobiodiversity. Okay. So we were talking the other day in 9.2 about how we're down to 14 different species of plants and animals that we're using. Agrobiodiversity, agriculture, life, diversity. That's what we're talking about there. So we're only using 14 total. Okay, so we have very low agrobiodiversity. That's your definition for agrobiodiversity, kind of like, or that's our example, I should say it that way. Agrobiodiversity is the agriculture's diversity. So we should have 300 different things. Or like Biggest Little Farm had 75 different types of stone fruits in their fruit basket. That is an example of high agrobiodiversity. Okay, at my house, I was planting, what was I planting the other day? Tomatoes, peppers, spinach, onions, asparagus, peas. I think there was 7 we were doing. I can't remember exactly. So I had 7. Okay, so my agrobiodiversity at my house, somewhere in the middle. Not great, not 75, but it's not like 1. So I'm not doing a monoculture. So agrobiodiversity can just like the difference of what the things are doing. So this protects genetic diversity with seed banks, and we talked about that kind of stuff. All right, harmful environmental impacts of industrialized meat. All right, so cheap meat produced by industrial agriculture has harmful environmental and health costs, not including pricing, violating full cost pricing factors, sustainability, which we talked about before. So overgrazing, we've talked about that. Overgrazing causes soil erosion. We've talked about that. Excessive water and energy use. Remember, 10 units of fossil fuel for 1 unit of food? That's overuse. Water pollution, all that pee and poop can unintentionally wash down into the water supply. All the fertilizers and all the pesticides, that was making the Mississippi River so nasty. Excessive antibiotic use, animal waste, all that stuff. We've talked about a lot of that. All right. Fish meal and fish oil. Those are the food sources for farm fish. They're often contaminated with toxins. those come from wild fish caught from the oceans. And then we get all those toxins, they get biomagnified in the human food web, and then it depletes the fish populations. Whole bunch of bad there. Basically, you have things that are toxic, they get into the human food web, not good for us, but by catching all the fish to begin with, those wild fish populations are going down. All right. So large amounts of waste is happening in those aquacultures. So basically, I was talking about Tacoma Narrows Marina. The kind of think of that like the ocean floor right under those nets. Just a really concentrated amount of fish waste right there. All right. The gene pool disruption by escaped fish because they still get out, and the overfishing of wild caught fisheries, that's still happening. Okay, a whole bunch of overexploitation. And like we said, it's hard for us to see, like look out in the ocean, like to see the impacts of the ocean because it's big. We can't really see the population numbers. We just think it's so big, there's just an inexhaustible resource. All right. So there's 9.3. Have a good day, guys.